Right, okay, so the Autogyro, I'm going to build another one, a Mk2, so I'm going to show you how I made that one today, and I'm going to show you all the extra parts that you're going to need if you want to make one yourself. Okay, obviously you're going to need a Lidl Glider. In addition to that, you're going to need some wood, radio gear, batteries, radio receivers, etc, etc. Okay, so first off, you're going to need some 1/16 ply, and that is to make the battery box and stiffener for the servos. You're going to need some 1/4 ply, that's for the engine mount and for the undercarriage. Okay, now undercarriage wise, again, you're obviously going to need some steel wire, and you're going to need some wheels. I think these are 3-inch wheels, so get yourself some suitable wheels. And you're going to need some sheet balsa to make the Autogyro blades out of, and this is going to need to be 4 inches wide by 36 inches in length, and the thickness is 6.5 mm thick. Okay, so you're also going to need 2 strips of 1/16 spruce, and that will go onto the edges. Okay, don't worry about the building of the Autogyro blades. I've done a video for that, so go and check that video out. Okay, so in addition to that, you're going to need some thick spruce to strengthen up the fuselage, because obviously it's quite flimsy. So you're going to need a length of that. Again, in the descriptions I'm going to give a breakdown as to what size and thickness that is. Okay, in addition to that, you're going to need a mast to mount the Autogyro head and blades onto. And in my local DIY store I found this fiberglass rod, which is quite suitable. There is enough in that to make 2 of them, so this is half of it. Okay, again, I'll give details of that. FFA concepts, I'll measure the thickness of that, but it is, I found the right thickness for the rotor head. Now obviously that's circular and the hole in there is round, so you'll obviously need to put some epoxy glue in there, drill it and put it on. I found it's on, it's secure. Now when we go speaking about the head, you can obviously make something up yourself, or you can do as I did, go on a website, Cool Wind. Okay, there's a guy there called Malcolm who runs the business, and he's made his own Autogyro heads, and this is the C30 Razor Autogyro head. So rather than faffing about making one, I bought one. Okay, in addition to that, you can also get a lot of other Autogyro parts, including the delta plate that's needed to mount the Autogyro blades on. So again, I'll give you details of that, but that's basically I think 0.8 thick fiberglass sheeting, and on the back of the instructions for it, it also shows you how to make one of those. So that's worthwhile investing if you want to make an Autogyro. Now obviously, to control the Autogyro head, you're going to need 2 servos, and they're going to need to be metal geared servos, because it's going to be under a lot of stress and strain. Now I use these Emax ESO8 MAs. I found they're quite capable. You're going to need a good rudder control, but I found just a standard 9-gram servo is all I needed for that. And then obviously you're going to need a motor, propeller and speed controller. Now I used a 30 amp speed controller. I know this is a 40 amp one, but this is all I've currently got available to make this second build out. And the motor, I used a Turnigy D28 26 1100 kV, and it needs to pull, you need to be able to get out of that minimum of 200 watts. Okay, I'm getting about 160, 180, but if you can get something that's capable of pulling 200 watts on a 10x6 prop, then you're well in there. Okay, now I also found that the batteries, I only needed a 1300 3S battery, and that gave me plenty of duration, but you could also go for a 1600 or a 1.4, somewhere in that region, as long as you can get it into your battery bay. Okay, so that's a run through of the parts that you're going to need to get hold of to do it. There is obviously major configuration and building on that, it's not just a simple quick slapdash and there you go, you got radio control autogyro. It is a lot more involved than my previous builds. So I'm going to take you through it step by step, and I'll see you in the next clip. Okay, so I've decided I'll go with the white and blue Lidl Glider rather than the black one, because with the Autogyro I'm going to need to have good visual reference, so I think the brighter the colour the better. So I've taken the cockpit off this one and swapped it onto there and put it on there because I just want brighter colours. So, and I think the white wing, or should I say the white tail plane, will look better. It'll stand out. I should be able to see it easier than the black version. Okay, so I've took the cockpit off, took the weight out of it. Okay, so the next thing I need to do, use a pen and draw around there, yeah, top and bottom, because I will need to cut them off. I don't need the wings, but I do need the centre section to hold it all firm. Okay, in addition to that, I'm going to need to put a strengthener in the fuselage, which is going to be this spruce. Now you may notice that the bottom of the fuselage is not completely flat. I'm not worried about that. It will bend up and it will fit in, and the angle of the tailplane will go up, but I'm not worried about that because the angle of my rotor I can also change to compensate for that. Okay, so that's my next task. Now that I've took the cockpit off, decided which bit I'm doing, I'm going to cut out the centre root, put that in there, make that solid, but I'm not going to glue it just yet. It's just to hold it solid. And then I'm going to clamp that onto there. I'm going to draw where I need it. I'm going to cut a groove out in order that I can slot that in. Okay, so I'm going to get on with that bit next. Okay, so now that the centre section has been cut out and temporarily put in place, I have used some clamps to clamp the wood, and I've centred it down the centre line, and I'm now going to use a pen to mark out where I need to cut. Okay, so it's a simple case of just draw on it. Try and get your mark as close to the wood as possible. Now my previous build, I didn't go with the wood all the way to the back here. As a result of that, when I did have a bad landing, I snapped the back off, which was no big deal because I obviously can glue it back on, but that's why you'll probably notice some splints on the other one, and that's the reason why. So on this build I'm going to continue the spruce support all the way to the back. Okay, so there we go, that's marked. So I'm now going to declamp that and cut that out. Now obviously we're going to be fitting a battery box in the front area. Right, so I've now cut a channel out to put the spruce spar in there. Now I may have gone a bit deep in a few places, and it doesn't look quite so pretty there, because I started dremeling it out and then I realised it's actually better to cut the foam into little cubes, pull the little cubes out, and then use the Dremel to flatten it out and make it smooth enough to fit in. So now the spar will fit in there. There you go. So the spar will fit in there, and as you can see it's not quite so pretty on that side. My Dremel slipped a bit, but on that side I've got it nice and straight. So I'm now going to have to cut all this lot out, slice it out, make a battery box, because I want the battery box to go to about that point there, and obviously the nose of that is not needed. So I'm going to make that battery box up now, and then I'll come back to you. So my next part was to cut off the nose of the model. Okay, so once I cut that off, hopefully you can see it there, I cut out the centre section at an angle because I want to keep as much flat. So that was the part I cut out. I didn't do it very too smoothly, I caught a bit there, but my main purpose was to get this flat area here, and then I made a battery box, slightly different from my first version. I wanted it slightly longer and slightly wider, and that was so I could get a bigger battery in it. So there's the measurements. I also wanted to put some down thrust on the motor, so I've added that on the box. So it's 170 mils long, 160 mil at the bottom, and 40 mil wide. So is the bottom, that's 40 mil wide. Okay, I put some ply on front, quarter ply, and that's 80 mil by 40 mil with slightly more on the top, but until it's done I won't know how much I will be cutting off. Okay, the ply sides are clamped on the side with some more box triangle balsa on the inside to reinforce it. I've got some ply on the inside and on the outside of the box, and this is for the undercarriage. Okay, now the undercarriage I made out of 12-inch long, so that was 2 pieces, 12-inch long wire, which I've bent to this pattern here. Drilled a hole in the bottom to hold it like that. The other one was made exactly the same, and the idea is to slot them in like that. Okay, with some ply sides will be glued in, and that will hold it all square. And then once it's all glued in place, I'll then put screws in to clamp it all down and hold it in place. Okay, so that will be the undercarriage. Obviously I will bend it further and better into shape, but the idea is to have it as wide as possible so that the model doesn't tilt over. Okay, the other thing I did is I strapped the wood to the bottom. I've cut the groove through. Let me just take these out of the way while I carry on. So I've cut and sanded out the middle of the fuselage. I put the box section in, and I use this Velcro strap to hold it in place overnight to keep it all flat. Okay, so the sides are now flat on that. Okay, the centre of the box I've marked up because I'm going to be gluing my spar on there like that, and that will go somewhere like that. Obviously I'll have to line it all up. That will go on there, that will go in like that. Okay, and that should give me the right amount of down thrust, but obviously I can add to that later. And we'll slice that in half, and then I'll be able to glue that on the side to finish the effect. I will then, because this is longer, I will need to add some balsa wood on the top, sand that to shape to suit the model there. Okay, so that's that bit I've got to get on with. In addition to that, I need to fit a mast in here and 2 servos to control the head. Okay, so what I've done is I've sanded the bottom of the centre part of the wing, and I've sanded the centre of the fuselage because there was a lug in there that helped hold that in place. Okay, now I've sanded that off to give me enough room to insert some 1/16 ply, and that was easily done by just putting the ply in there, draw the mark where I want to put it in. Now I can slide that in place to hold it all rigid and strong, and the reason for that is I need to cut a hole through for my servos. Having that ply there will reinforce it so the servos can pull and be nice and strong. When I drill the mast through, the mast will go through that and through the ply right to the bottom, and that'll give me a strong secure fixing. Okay, so I shall crack on with gluing these in places, and then I'll get back to you, because we've got to cut the rudder out as well, fit the rudder servo. So that's the spar glued in place. I've glued a little bit of ply on the front, as you can see there. Now undercarriage I'm going to just put in place. So, okay, get the glue. Now I'll be building that up with more ply, gluing in there and around this area to strengthen it all up. That's a set. There we go. I think that's set now. Take these out just for now. There we go, hopefully you can see that. So there's ply on the outside of the box, ply on the inside of the box, and 2 holes drilled through to accept that. Now I need to get some glue. Glue it in here. Just do a test fit. There we go. Yeah, that can look good. Right, get the glue, get that glued in. That's making it very strong, and then when it's glued in I'm going to cut that part off. In fact, I could mark that now and cut it off, kind of. Was there. I'll cut it at an angle just to neaten it up. So after splitting the nose and a bit of sanding, I've glued it on the front, and that's what I did. So I cut it down the centre, sanded it off nice and flat, and so I can glue it in place on the front like that. And I think you'll agree that completes the look of the glider. So I'm going to stick that other piece on now, and then I can carry on with the rest of the build. Okay, so now most of the work on the fuselage is done. It's time to make a hole for the mast to go in. Okay, so from this cockpit line here, measure 2 inches. 2 inches back, okay, and use a protractor. Okay, so moving on with the build, the next part of the build I did is I fitted a control horn on the rear to act as a tail skid, because if you look on the some of my previous videos, you'll notice without a skid of some description the tail will just swish around. So that's to dig into the grass and give me some stability. In addition to that, I've cut the fin off, okay, because I'm going to be using that as a rudder. Okay, and what I did, I found some plastic tube and some carbon fibre that would slot into it, but even fiberglass or anything you can find, biro, you just need something that you can make a bush for with that in there. Okay, so I've drilled a hole through there, fitted the bush, and then fitted the fin in position and continued drilling through to make that. So that has now been glued into the fin. I have a servo arm glued onto that. That's glued in there. Now, if you've ever seen these prop plastic rings that you get for the prop to adjust for the motor mount, save them, because I find them useful for using as bushes. So this one's slightly too big. Found one that was slightly too small, and I've drilled that out so it's a tight fit on there. So now that will slide in there, and this will push on there, keeping it in place. And we'll probably put some super glue on that later. But now I have a nice all moving tail. I've also decided to fit it in reverse because that end is less of a sticking up than if I'd have had it the other way, sticking up. My next part of the build was to mark out where I'm fitting the servos. Okay, now this one here is for the rudder, because obviously I've got no wings in the way, and the previous one I fitted it there. I'm fitting it there this time because I don't have any wings in the way, and that position was determined by how long my control rod was. Okay, so when that was put into there, that allowed me to decide where I'm going to fit the servo. Okay, which is there like that. I'll say that. Okay, with that, the benefit of that being there as well is it not only does it look a bit more streamlined, but it does allow me to get the full movement, whereas previously when I had it up there, it was fouling on the rudder when it was in that position. It was okay in that position, but as soon as it went in that position, it would foul. Okay, where else are we? So yeah, the servos, okay, they need to be cut out. Now for the rudder, a standard 9-gram servo, but for the control head you will need metal gauge servos, and these are the Emax ones. Okay, so I've got that to do next. So now that I've marked them, I can remove that section, use a knife, cut the slots out, make a hole through for the wires to come through into the cockpit area, and then when I'm happy I can glue all this in position and strap it down, because this piece of ply will help stop the servos from pulling up. Obviously the fin one, there's not a great deal of load on that one, but these servos are actually holding the model up, so that's why I put the ply there. Okay, so now that I have fitted the servos in place, I need to work out where the mast is going. So I put the centre part of the wing back in again, making sure that the wire for the servo, the rear servo, is not going to get in the way of this. That's temporary out of the way. Put that in there, put my ply in there. So I'm going to leave that out just while I'm showing you what I did. I used a bit of brass tube to bore a hole through. When it reached the ply, it made a mark, so I drilled the hole through the ply, which for me was 45 mils back from the leading edge. Okay, now that there, I was aiming for around 10 to 15 degrees rearward angle. Now I'm gauging off the tail plane, so I'm going to use this as a guide, and if I line that up with the tail plane, or where the tail plane will be fitted, you'll now be able to see there's a lot of upthrust in that, which I was quite surprised with, but hopefully you'll be able to see it. I've got down thrust in my motor mount, and what we're looking at, let me just remove this for the time being so you can see what was done. So I put that in there, I've already bored through, put that back there as my Dayton line, which is there, use a protractor to intersect that there, and you should be able to see there I've got about 10 to 11 degrees back, so there's 90, there's 10 rearward angle, and that's what you're aiming for, somewhere there, and then obviously you can adjust the head afterwards. Okay, so once the hole was bored and the ply hole was done, okay, so I'm going to put the ply in there, push that back in again. Okay, obviously I've got to glue all this back in, and the mast should fit in, and check that you get your 10 to 15 degrees back angle. Okay, now this mast, this fiberglass mast, is 12 inches long. Okay, so I now that I've got the holes bored, you might not get it perfect, don't worry about that, gouge your hole and work it out. I'm going to fill this in with a lot of epoxy glue to hold it in place. Okay, so I'm going to glue that in place, make sure I've got my servo wire in place but not trapped. Then I'm going to glue that in place, and then I'm going to mix a load of epoxy glue in and pour it down that hole to fill up as much of space as I can, and then it will be time to fit the mast. So I'll show you the mast after I've glued that in place. Okay, so I'll see you in a bit. Okay, hello again, here I am. So now I've glued the mast into position, this fiberglass rod, and that has been epoxied in, and that is strong. Now prior to me doing that, I fitted the head on and drilled a hole through and put a bolt on, lined it up so that while the glue is setting I can put it in and make sure that this is set at 90 degrees. Okay, so it's level with that, and checked everything's set up. Okay, when that was done, took it off, glued that in position. Now the height of this and the height position of the servos was all determined by how long I can get my rods. Now these are bicycle spokes, 2mm bicycle spokes, 300mm long, 298 to be precise, but 300. So that determines what I have. And this is Mark II. I decided to make my mast longer than the previous one because I was getting blade strikes onto the rudder at the back, so if I move it up a bit it should help that. Okay, now as discussed before, the angle, rearward angle of this mast, you aim for about 10 to 15 degrees rearward angle using your tail plane as your datum line. Okay, in addition to that you're going to need some down thrust on the motor, again the usual, about 3 to 5 degrees, what you would normally expect on an airplane, fixed wing plane. Now the reason why this is angled back is so that when it's flying through the air, as it's being dragged through the air, the blades are being dragged through the air, it will windmill, auto rotate, so not like that at an angle. Okay, and you set the head up to about 90 degrees to that. Now obviously we can alter that. Oops, move that. These are only temporary at the moment while I show you. So we're looking at that being set up at 90 degrees initially. Okay, we'll set all that up and then do trimming flights, because this may need to go further back or further forward. You may need right as well. So initially aim for 10 to 15 degrees back on the mast. Make sure that when it's glued in that your head is set at 90 degrees like that, so that it will run to the rods perfectly. Now the reason why we have metal rods, these are just metal rods at the front and not at the back, because I said that the blades are angled like that, so they constantly want to going to pull back, and it's better that the tension is being pulled on these rods rather than being compressed in the rods. They would bend. Okay, so that's the reason why that is there. I've decided to move the servo lower down because it allows me more movement on my servo, because before this part would hit that and that would restrict the amount of control throw I could have, and experience of flying the other Autogyro is I need as much control over the rudder as possible. Now the tail plane, I haven't done anything with that. I've left that as it is, it just slots in. My reasoning behind that is if it does get a strike on a knock, I'd rather that pull out and fall out rather than break. Plus if it does break, I can always slot another one in. Okay, the motor I've put it roughly the same position, which is just above there, with the thrust line is here, above here. That's where it worked out from before on that. Okay, so that's where we're at the moment. I've now obviously got to infill that with a bit of wood or foam. I've got to fit the undercarriage and something to hold the speed controller. And while we're on the speed controller, this is my speed controller. A 30 amp speed controller is all that's needed. So here's the completed Autogyro, and as you can see, I've now glued in the glass fibre rotor shaft. I have the rotor head attached and glued in place. I have the wheels fitted and screwed in position. That's now nice and secure. You want to try and get your wheels as far forward as possible, and if you're wondering why that angle was like that, it's so that there is plenty of room for the prop to spin, but the wheels are in line with the prop or a bit further forward. Okay, and now that it's finished, I've put the battery and a receiver in it. I haven't put the head on it as yet, and I estimate it to come out about 690 grams of weight. Now, until I can get out and get flying, I won't know the true angle of this head. Okay, I only estimated this head, this rotor shaft, this rearward angle off the Mk2 glider that I did, so that's the same angle as that one. So whether or not this head will need to come lower down or not, I've no idea, but as it stands at the moment, if I balance it at that point there, you'll see that the rotor shaft is in a vertical line, it's straight down, and I'm hoping to use that as an indication as to whether or not it's hit its CAGR mark, but I've no idea until I can actually get out and fly it. So there it is. This is a true Autogyro with no wings on, and it may well be a lot different than the Mk2, which had its wings on. So as I say, I have no idea on that. So here's a closer look at the Mk2 Autogyro I did. As you can see that the rotor shaft on this one is a lot shorter than Mk2, and due to that I was getting blade strikes on there, so that's the reason why on Mk2 I've increased the height of that, and the height of it is only about the same as that shaft, but as to the angle of the shaft, I've no idea whether it's correct on Mk2 or not. I've estimated it on this one, but that gives you an idea. That is in its trimmed state with the head like that. As you can see, that is practically 90 degrees to this shaft, and the shaft is about 10 to 12 degrees rearward angle, and these are the wings that go on it. Okay, so I will in a future one try and reduce these, or not try, I will reduce the length of these and see how much it affects it. But if you are they obviously need taping in place. Let me just take these off while I talk a bit more. Right, but if you are going to have a go at Autogyros, I would recommend trying this version first with wings on, because if you're used to flying Autogyros, if you are used to flying aeroplanes, you'll have gotten used to the angle of the wings as it flies through, and know how to control it. Yeah, with an Autogyro with no wings on and the blades are spinning, you won't have very much of a visual reference to look at. That's why you have to keep them close, so your only visual reference will be the wheels and maybe the tailplane, so it'll be very hard to concentrate on how it is. And with Autogyros, you mustn't bank them over too far, because if you bank them over too far, like a sailboat, when it's sailing in the water and doing a turn, it will bank left and right. Yeah, but if you tip the boat over too forward, it's going to sink. Exactly the same with Autogyros, I've discovered. So when you try and make a turn, keep it shallow as possible, and use the rudder, because you can turn like that, which is much better, and that's why you need a lot of rudder control. Okay, so there's that one. So I'll leave that up to you whether or not you want to have a go at autogyros. The biggest building problem will be making the blades. The actual cutting all this out and making it the way it is relatively straightforward and simple, especially if you've built planes before. And it's certainly a novel to fly. It's not quite like a helicopter and not quite like an airplane. It's somewhere in between the two. But if you've flown aircraft before, this is probably going to be easier for you than helicopters. Okay, so we'll leave it there for time being, and I'll see you in a future video.